So, trigonometry. This was the question over here. Pretty common trig question. Solve cos 2x is equal to 0, right? Some people like doing that graphically, some people like doing it purely algebraically. Either way, here is my solution. All right, what do we like about it? Do we like anything about it?
Oh, I love that. What if I agree? Oh.
Is that one of the answers?
No. Oh, it might be,
Oh.
to be honest. But
Okay.
I did all my radians. So
Oh, why'd you do that?
because you meant to.
Oh, because you meant to. That's the first mistake. Well done. So the first thing that you need to do is read the question carefully, right? And that's actually going back to, I'm pretty sure I've written that somewhere as well, but it's worth writing again because reading the question means different things in different scenarios, right? Sometimes they want you to round to decimals. Sometimes they don't want you to round to decimals. Sometimes they want you to solve in radians. Sometimes they want you to solve in degrees. How do you know? Well, it says 4, 0 to 2 pi. That's something we learned in year 11, something called radians. Pretty much all of the questions that you do will be done in radians, particularly when you're doing integration. Anytime you use calculus, it is always asking for radians. So just make a note of that calculus always uses radians if you're using trig, right? They may be a bit tricky every now and then with circles. They like to do that in degrees sometimes when you're finding like sectors and things like that. But calculus always uses radians, okay? Cool, let's go back to this one. Anything else that we think?
You only got one solution.
I only got one solution. Trig equations are always going to have multiple solutions, right? So trig equations, almost always I should say, have multiple solutions. Tamara, do you remember how we get those other solutions? Do we draw anything in particular for that? Or what do we draw? Yeah, you can draw a graph, you can draw a unit circle. The tricky thing, and this is something that sometimes catches students off guard, the tricky thing with the unit circle is like when you have things on like the border, right? Like it's easy enough to identify the quadrant that you need, but when you have things on the border, so like 0 degrees is here, 90 degrees is here, right? Then it gets a little bit confusing. Hey, which one's the next solution? Like which quadrant is it? Like, yeah, this is where cos is positive, but what about when cos is 0? Like how does that work, right? So that's when I usually rely on the graph, and then that's when you have to know your value. So this is 90 degrees. And what was the next point where it's 0 tomorrow? Do you remember? 270, right? So actually, we should add in 270 over here, right? So here's that fixed over here. So cos 2x equals 0, 2x equals to 90, 270, x is equal to 45. Then you can halve it afterwards. Never halve it beforehand or anything. You might do something dodgy there, right? You can only halve it at this point here. Is this what you guys got? Are you happy with that one? Yeah? Christian? Two more? Where are we going to get the two other solutions? Okay, again, another trick, right? Because, right, just like trick after trick here, right? Because we have cos of 2x. And what does that mean? Well, when you have this domain, that's for x itself. If you want the domain for 2x, how do you get the domain for 2x? Well, you just have to double everything, right? So cos of 2x, the domain would be 0 to 4 pi over here. Now, we've already established that we should be working in degrees here. So again, this is technically wrong because it's in degrees, right? Nothing wrong with starting in degrees and then going back after that. If you can work completely in radians, that's fine too. But I know a lot of people prefer working with degrees and then going back that way. I personally don't really see a problem with that. So let's start with the solution properly now. Cos of 2x is equal to 0. Making a note that my solutions should be going from, if I'm working with degrees first, 0 to not 360, but double that, right? So 720 degrees, right? So then let's have a go at that. So 2x will equal to, what am I getting? So I need 90, 270. And then what you can actually do is you can just add 360 to these solutions here because you know that you're doing 2 revolutions around, right? If you need a graphical approach to that, you can do that as well. What would these values be then? That would be like, that's 450. And what's the other one? Anyone got it? 630, cool. And then I can halve them, assuming I did that correctly. And then I can say, well, but we want the answers in radians. So x is equal to pi on 4, 3 pi on 4, yep. Yeah, you just divide all these by 180, and that will give you that. Was it 5 pi?
5 and 7.
5 pi on 4 and 7 pi on 4? Perfect, okay. And that's pretty much perfect solution. I mean, ideally, you might even want to write that in radians, but again, like I actually like working with degrees personally, so that's kind of your choice. I'll leave it up to you. All right, that's the our most ideal solution or something like that. Questions on that one? Yeah, yeah, cool.